I would like to show an important property, which is that the flux follows an inverse square law. If you consider an isolated star, like here in the figure, and you put spherical surfaces, so you can write that if the energy is proportional to the area, and you write that the energy is the same, energy that is crossing the surface little s is equal to the energy that is crossing the surface big S. That means that so the flux that crosses the surface little s times the area of that surface is the same as the flux that is crossing the surface big S times the area of that surface. You cut the 4 pi's on both sides and you have the property that the flux at the distance r is equal to the flux at the distance big R times big R over little r squared. That is, the flux follows with the square of the distance, as we wanted to demonstrate. And this is easily understandable geometrically. This is simply a statement of conservation of energy. A great radii, the same amount of energy, disperses through a larger area. So the flux, which is the energy per area, has to decrease at the same rate that the area increases. The area increases obviously with the square of the radius. Therefore, to conserve energy, the flux has to decrease with the square of the radius. It's simply a geometrical dilution of the energy spreading over a larger and larger area.